Hey everyone. So today we're looking at a major upgrade to how our robot turns. Up until now, we've been using motor rotations to turn. For example, if we told the robot to turn right and we wanted a 90-degree rotation, we had to troubleshoot it and figure out it was about 0.85 rotations. That got us to 90 degrees. It worked okay at first, but have you noticed that sometimes the robot turns perfectly and other times it turns far too much or comes up a little bit short? That inconsistency is the number one enemy in First Lego League. Let's try this out. So this is with our old code. I'm going to set it up, same exact spot. Notice the turn. Kind of did a little jerk in the turn. So it did do what we wanted it. But do this 10 times in a row, and it's not going to end at the same spot. I did it a few times, and it was actually ending right over there, even when I launched it at the same spot. So I'm going to put it in the same exact spot as we just started. All right. So this time we're going to use something new. We're going to use the gyro. So in the Spike Hub, we have a built-in compass called the gyro. It measures the physical yaw angle, or how much the robot is actually spinning in the real world. And I actually built a custom MyBlock for us to use. Instead of guessing motor spins like we did before with the 0.85, this MyBlock will tell it, start turning right and keep looking at your gyro compass. Do not stop until you actually hit the exact angle that we asked for. So when I told it what to do after I wrote this MyBlock, gyro right 90. That's the degrees. I wanted exactly 90 degrees for that turn. Now, part of this, you'll notice this little bit of math here. It says degrees minus 2. So why did I do that? Because our robot is heavy. And when the brakes hit, this momentum carries it just a little bit forward. So stopping at 88 degrees lets it slide perfectly into 90. This means that even if our battery is dying or the wheels slip, the gyro will keep the motor spinning until we hit our exact target. All right, let's check this out. Using our aiming jig, we're lined up. Now compare this turn to the turn we did before. One consistent moment. It also paused. So instead of braking this time, I added a hold position block so that the gyro could take a little bit of time to calibrate, just a half a second. Same thing as before. Notice we had a perfect turn. And that is what I wanted. All right. So the best part of all this is that this MyBlock here, I can actually go into it and I can say, oh, I don't want a 90-degree angle this time. I actually want a 45-degree angle. So say I go into my code again. I have a MyBlock right here. And I want to still turn right at 45 degrees. I'm not going to type 90 this time. I'm going to do 45. And it will turn at exactly that 45-degree angle. I could do any angle. The extension to this is I also want a gyro left, just to be consistent. I could use some negative numbers here, but I want to recreate my block, but instead of titling it gyro right, I'm going to do gyro left. And instead of right 50, I'm going to do left 50. So consider using that in your next go.